Hi everyone, this is the first tutorial of the in-depth analysis of global illumination proxy system. The version we are going to use is the one including the SkyMaster Ultimate, but it's the same version across all other packages inclusions, or the standalone package as well. So let's begin with the basics. We will see the sunlight, the spotlight and the point lights. So let's begin by having a look at how the system works. We have an atrium scene here. We have also from SkyMaster some volumetric lighting here, as we can see from the sun. This is subtle volumetric lighting, which goes very well with the system, generally, from the sun only. It's nice to have. So we hit play. And we can have a look at what's happening by enabling the gizmos. So we see the sunlight is creating some point lights. This is standard unity point lights. So there's full compatibility with every platform and system. Also, there is nothing special used in shaders, etc., or image effects to have the global illumination. So we see here that the sun has added 4 lights. Also, we have here a spotlight. Here that adds another light here. And we will explain a bit how this light is created and regulated. But let's start with the sunlight. If we turn it off, we can see that it's gone. So also I have enabled another idea that is only in this tutorial, that we can also have a duplicate of the script, of the sunlight script, that creates a GI and create higher harmonics. So these 2 lights are created by higher harmonics, which means the lights are created farther away from the surfaces. So we can have some lights created with one script near the surface to catch the local detail, and some lights created more above the surface to create a global detail. Also, we can have only the global lights, the harmonic lights, so we have more diffusion. And for example, PBR materials don't have issue with very local lighting. So let's see a bit how the system is set up first. Also, I noticed I have enabled the demo 2 times here. So this is on the side. I will check for the final demo because I duplicated the script 2 times with 2 lights. So also I see here that the sunlight is automatically enabled. So this should not go. So this is the first light. The main sunlight is this one. So we have this light. We have the light collision script, which is the main script that does all the work. And here I have this demo that creates the GUI and controls some effects. This is not for the main system, just for this demo. So I have duplicated all these things. We have another. This light needs to be here, but it doesn't have to be activated for the higher harmonics. The light collision script, and I remove the demo here. So let's see, these lights will remain off when under the play mode. Okay, it remains off, that's good. So this is how we set up the higher harmonics. We duplicate the script and with a switched off light. And of course this demo should not be there because it's just a duplicate, it needs it only one time. So let's remove the demo here. So let's see how to do the main setup. So we have our sunlight. You can see it here by moving. It has an intensity. These settings can be anything. So let's begin by seeing what the script does, the light collision script. Let's extend a bit. So we can set, for example, we can set where the lights are these lights are created, the bounce lights. They can be created by tag or by layer or cut below some height. So all of these some options that can be enabled to control the effect. We will not use this right now. We can enable secondary bounces and make the lights of the secondary bounces not important by using this option. We can also check for secondary collisions. This means that when a light bounces, for example, a light is here, it bounces here, and create a bounce light here. If there is an obstacle here, in the middle, then this should avoid this creating the light inside the obstacle, for example. And mid halfway means that the light will be either in the spot where it's hit, in this case, or in the middle of between the obstacle and the surface. So this is a new option that was needed by some users, so I added it. So let's see now. For the sunlight, it's useful to create a grid around the light. So this grid is a grid that is created on the floor around the hit point. So if the ray from the sun to its forward vector hits the floor here, for example, it will create an array of lights around this place. So we can see we have the sampling distance, we have max positions, so we can have 55 lights, for example, and how much is extended this around, for example, our hit point, our grid. So note also that because we have a player here, so we can say who is our player here. Let's say that is the camera, actually. And then this will create a virtual ray that comes from the sun towards the camera, near the camera somewhere, in the direction of the sun, of course, and create the grid around the player. So this is also useful for creating a grid around the player as he moves. So let's see. We can have tag placed player with the player tag, otherwise it's the main camera. We can see some offset here to create the grid from the player with an offset, for example. So if we need the lights to be in front of the player, we put the Z to 25 to have the grid in front of the player, than have useless lights behind him, for example. So this is one of the main things to consider. Let's now, let's start by disabling this local light here so it doesn't confuse, and hit play, and let's see how this works. So as our player moves, the lights are created in front of him, as we see, from the sun, but only where the sun hits. So this is important. And so this can enable an infinite map, actually, using GI, and we can see how the harmonics work also. So the low lights are from the main light here, it's from our main light here, which is using also, by the way, another setup thing is the pool that holds the lights, must be set up, light pool. So it's just an empty game object that holds the lights, as we see here, the bounce lights. So if we want to disable this bounce lights, for example, of the first harmonic, we just remove to see which is the lights, just debug. So this is first harmonic, this is second harmonic. This is more diffuse, more up from the ground. Okay, so since we talk about this, let's see how to define this more up from the ground. So we have this option here, offset on normal. This will, when the light hits, it will offset it. It will create a bounce light that is from the hit point towards the normal of the surface, and an amount that is here, placement offset, that is defined here. So for the first harmonic, we put towards the offset normal 2.6 meters, and for the second harmonic, we have chosen not to put offset on normal, so this will not follow the normal of the surface. It will just bounce towards the hit direction, and we have put placement 5, so this will be created more above, and we can put more, or we can put more harmonics even, to make even more diffuse lights. And each harmonic should have a bit bigger intensity. So we can see that the intensity is defined here, divide initial intensity. So this factor says when the light is first created, how much is divided until it goes to the maximum. And the bounce intensity, because we need to be smooth effect. And here we have the bounce intensity. So bounce intensity is how strong will be the bounce light when it reaches its maximum after it's created by this initial value. divided by this initial value. And then we have the appear speed, which is how fast this transition will happen, and the degrade speed, which is how fast the lights will be disappeared. As we move, for example, away from this area back, we see lights disappear and new lights appear. So these cover the most important aspects of the system: the creation of lights, how they are created in the normal or not, and how far, and how to define the initial division of the power, and how to define the maximum power, and how to define the speeds of these lights appear. And also we can see the grid, because the grid is all these rays are defined by the grid option that we talked about here, use grid, and these parameters. So these rays are cast in a grid around the player as he moves, and that's why they disappear after a bit in the distance. So this concludes basically the definition of for the sun and for infinite maps and the grid around the player. You can see the bow lines here. We can actually also do further calculations on these lights if we need, because we can grab them and do anything with them. For example, I can top them off or on easily through the GUI here, but any script can be used to do these things. Okay, now we can disable this the sunlight. I will disable also the harmonic, because the demo was not made for the harmonic actually. So the harmonic will remain. That's the thing. And let me close just manually the sunlight GI. So this is without any GI now, the system. So let's see a bit about the spotlights. So let's see the hero spotlight. There's a spotlight parented to the camera, so we can see here that it casts a single light that creates GI. So actually 3 lights. So this is without GI, this is with GI. And this is governed by this place here. This is the player, this is the pool. So you can see spotlight. So this is parented here. This is the player spotlight. This one. So we have the spotlight here, and we have the light collision script again that does the work. Here we can see the difference is that we don't use a grid, because we get just the light where it bounces near the bounce points. What happens here is that one light is created each time it hits, but there is a delay to destroy the lights. So these delays to destroy the lights are both time-based, here not time-based, but are time-based when they go out of scope, and position-based. So we take the last position of the hit, which is this one, compare it to the previous positions, and we remove previous positions if they are far. That's what happens here in the spotlights. So we can see that here is the main things that govern this behavior. Minimum distance to last light. So this is the main actually variable. So if the distance is above 6 meters, for example, to the last light created, this one, it will eliminate the light. And then there is some density of the lights, so it doesn't create lights very close. So the parameters dictate this light creation when one light and no grid is used. There's also follow distance, etc. etc. So there is some options also to get hit color, get texture color from the texture. This option will get the texture of the surface, for example, like this one. It's red now. You see. If I remove these options, we see that the light is white. It's not red anymore. So we can enable these options to grab the texture and color of the surface. We see that the color here becomes purple, for example, when it hits. Here it becomes red. You can see the color change speed also. so these colors can change in a lower manner or faster. And this is the maximum distance to camera, so this is another cutoff, so if the light is very far, the bounce light is very far away from the camera, we'll disable. And you see here that we give offset. Also, this is an important variable. This must be enabled to give this offset from the surface, as we said here, and on normal. So also just keep in mind this, that this offset, to get this offset from the surface, also this checkbox must be enabled. And if you need extra to be offset from normal, this checkbox also must be enabled. So let's see, let's remove this light now, and let's add this local light I added to showcase this system that checks secondary collisions. So we see we have a spotlight here. This is our spotlight. What is it? This one. So this is a spotlight. We can see it in the scene. It's this one. So it hits the surface somewhere here. We can see that it has hit the surface here somewhere and then creates a bounce somewhere up here. But the problem is now that we have this sphere here. So the bounce should be somewhere here, as the purple line shows. But the light is created in the middle between the sphere and the bounce point. So how this happens? It's this new parameter we talked about, this one. So it checks for secondary collisions. It checks the bounce from the bounce point to the bounce, from the hit point to the bounce point here. And if it finds the sphere, for example, it will meet halfway and the light will be created halfway between these things. If it's not halfway, the light will be created down here in the hit point. If we remove this one, the light will be created here in the point that was originally found before checking for collisions. So this is very useful actually, because some users have problem with lights going inside surfaces, so this generally should be enabled if it's needed. So that concludes also the spotlight generally, and we can also have a look now at the point light. So the point light is also not very far from what we have seen so far. Let's enable, this is the point light here, and let's enable a sample point light with a script. So this is our point light here. It has a range, a radius, all these things. Then it has the script light collisions also. This also can use a grid, because we need to create, for example, around the light, because it's a round light. So we use the grid options in this light also. So let's move this light around and see what happens. We can see light created all around as it moves, using the same rules for the collisions, for everything as we talked about, for the light speeds. And so we can see now how the light affects the environment. I see I have also created a way to move it in game time. That's good. So we can move the light around, create bounce lights. We can turn off the sunlight a bit in the ambient. Check what happened here. You can see near the red, it gives a more red light, as it should. Here become more white. If we take it back here, creates the ambience here. So the main difference with the point light is that we create again a grid. We don't need to put much extent here, because the grid is created around this light in a radial fashion. We have also the horizontal directions, which is how many horizontal and how many vertical directions will be around this sphere cast. And here we have the point light properties, that is the radius. and the red is for the secondary hits, for the secondary bounces, if secondary bounces are used here. So this is the main differences to the spot and the sunlight, these options here for the point light. These options are similarly used as before. We can see the moving distances to camera. You can see also the offset, placement offset to meters. And so this also concludes the point light properties. And we can see also in PBR materials that if we use the offset a lot, then the PBR materials will not be affected with very, very close lights and look like very point lights near the surface. So this surface on normal options and the distance may affect the scene depending on our needs. And so we have covered most of the things. The pool for each of these light collision script, it's best to define a different light pool. It's an empty game object that holds the lights. That's better to be different for each of these light collision scripts that are added to our system. And this concludes the detailed tutorial on global illumination proxy, and we saw how to add the script to any light, to any of the light type, how to control for the sun with the grid, with the spotlight with the distances, and the point light with the horizontal rays grid. And we saw also how to define by layers the collisions, how to grab the color, how to control the speed of the colors. And this concludes the detailed tutorial for global illumination proxy. Thank you for attending.